Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ainazar binti Muhammad Nazi, and today I would like to present my FYP presentation entitled Adsorption of Methylene Blue using Natural Waste for Wastewater Treatment. So in this presentation, I will be explaining about the introduction, literature review, methodology, results and discussion, and conclusion and recommendation. Introduction, background of study. The presence of dye in textile industry influence contributes to water toxicity. So in order to achieve maximum pollutant dye removal, a suitable adsorbent must be chosen. So the purpose of this research is to look into pollen leaf as a potential adsorbent for methylene blue adsorption in wastewater treatment. Problem statement. Among other industries that use dyes, textile industry is the major source of water pollution. Textile dyes are highly complex because it contains many dyes and additives. Due to low biodegradability and bioefficacy, the traditional biological treatment is ineffective in treating dyes in wastewater. Significance of study. In this study, pollen leaf from various plants were used as a potential adsorbent for removing dyes from wastewater. Pollen leaves are widely available and does not require any additional pre-treatment. So as a result, the cost for using these leaves are reduced. These leaves have no commercial value. Thus, using pollen leaf as an adsorbent helps in reducing waste. Objective of the study is to prepare a national adsorbent powder from pollen leaf to investigate the adsorption capacity of untreated pollen leaves according to the variation of methylene leaf concentration, adsorbent dosage, adsorbent size, and contact time for the adsorption of methylene blue in aqueous solution. To study on Langmuir and Trundle isotope for the equilibrium adsorption process of methylene blue dye using pollen leaf powders. Literature review. Methylene blue is a monovalent cationic dye and is highly soluble. It is a popular dye used for dyeing cotton and soap. The discharge of methylene blue effluents into water interferes with the chemical processes of aquatic plants. Adsorption. Adsorption is defined as a substance accumulation at the interface of two phases, which is liquid-liquid, gas-liquid, gas-solid, and liquid-solid. Adsorbate is the substance that accumulates at the interface, and adsorbent is the solid on which adsorption process takes place. So this method is promising for treating polluted waters, particularly if the adsorbent does not require any treatment before application. Pollen leaves. Pollen leaf waste have received increased attention among other adsorbents owing to its low cost and widespread availability. Pollen leaves pollutes the environment due to its disposal program. So as a result, pollen leaves may be investigated as a new potential adsorbents with the goal of creating a cleaner environment. Methodology. So the material used in this study was a pollen leaf sample that were taken from ground which were collected from various plants at Shah Alam Lake Garden Section 7, and the chemical used was methylene blue. Preparation of the adsorbent. The sample was dried overnight in an oven. The dried sample was ground and sieved into different sizes. The sample was then kept in an airtight container. Preparation of methylene blue stock solution. 4,000 ppm concentration, 0.25 gram of methylene blue powder was dissolved in 250 ml of distilled water. So in order to achieve desired concentration, dilution solutions from the stock solution were made for each batch adsorption studies. The concentration of methylene blue was determined using UV spectrophotometer in order to obtain maximum wavelength. Results and discussion for batch adsorption studies. Effect of adsorbent sizes. It was done by varying the pollen leaf particle ranging in size from 125 to 600 micrometer while keeping other parameters constant. So from this figure, it shows that the larger the particle size, the lower the percentage removal of methylene blue dye. According to Tang EPAL 2017, smaller particles had larger surface area than larger particles, which leads to more available adsorption active sites and as a result, higher percentage removal. So the surface area exposed for MB adsorption increases as the particle size decreases. Therefore, the adsorbent particle size of 125 micrometer were chosen for the remaining batch adsorption studies. Next is effect of methylene blue concentration. It was done by varying the methylene blue solution ranging in concentration from 20 to 100 ppm while keeping other parameters constant. So from the figure, it shows that percentage removal of MB decreases with increasing methylene blue concentrations. So according to Muller's Hewa ETL D21, at higher concentration, most of the dye could not make contact with the active surface sites because the active sites may have been occupied by the methylene blue molecules. Hence, as dye concentration increased, no further adsorption process could occur, resulting in decreased dye removal. Therefore, a MD concentration of 20 ppm was chosen for the remaining batch absorption studies. Next is effect of adsorbent dosage. It was done by varying the following leaf particles in dosages ranging from 0.5 gram to 2.5 gram while keeping other parameters constant. So from this figure, it shows that as the adsorbent dosage increases, the percentage removal of the methylene glucide also increases. According to Amuda ETL 2020, this was most likely due to the resistance to mass dye transfer from a bulk liquid to a solid surface, which becomes significant at high adsorbent loading. This was also when confirmed that the intensity of the solution color changing from blue, which indicates the lowest dose, to yellow, which indicates the highest dose. So since the percentage removal of the methylene blue does increase significantly at the absorbent dosage of 1.0 gram, so it was chosen for the remaining batch absorption studies. Effect of contact time. It was done by running the contact time ranging from 10 to 15 minutes while keeping other parameters constant. So from this figure, it shows that the longer the contact time between the adsorbent and the adsorbate, the greater the percentage removal of methylene blue dye. So it says that there was no further increase in the amount of methylene blue absorbed by the adsorbent after this stage, which implying that the adsorbent material requires at least 15 minutes to absorb the maximum amount of methylene blue. According to Holiday ETL 2022, this was due to the mixture had not yet reaching the equilibrium and only a few active absorption sites were being filled. Therefore, the contact time of 15 minutes was chosen for the remaining batch absorption studies. Results and discussion absorption acetone. Based on the linear regression and coefficient, the R square, the friendly acetone plot with R square of 0.9 nitron was better suited to the absorption data in the studied MD concentration range compared to the Langway acetone plot with R square of 0.9698. This shows that the friendly absorption acetone can better describe the absorption process of untreated final leaves on methylene blue, where it suggests multi-layer absorption takes place on the absorbent surface. Results and discussion characterization of the absorbent SEM analysis. This figure shows the SEM image of the absorbent before and after methylene blue absorption at 3000 magnification. Figure of the absorbent before absorption process depicts rough and irregular surface of untreated corneal leaf with significant number of pores. According to Beck et al. 2010, rough and porous surface provide better absorption. Figure of the adsorbent after the adsorption process showed the MP-dye molecules were adsorbed at the adsorbent surface, significantly altering the morphology of the adsorbent surface. After methylene blue adsorption, the adsorbent surface becomes smooth and porous, indicating that NB-dye molecules filled the pores. FTIR analysis. This figure shows the FTIR spectra of 100 ppm methylene blue, the untreated pollen leaf before absorption, and untreated pollen leaf after absorption spectra. So after MB absorption, FTIR spectra revealed significant changes in functional group bands, while signal intensities in some bands decreased and several new peaks were observed in the fingerprint region. So the 1161.78 centimeter negative 1 band was attributed to the CEO stretching in the adsorbent lignin molecules. Previous research has shown that different functional groups found in sleep, such as cellulose, hemicellulose, lignins, and pigments, have a beneficial effect by generating active binding site for dye adsorption. So to summarize, FDR analysis revealed that untreated corneal leaf had a functional group of OH, COOH, and HNCO, which could be a potential absorption site for MD dye. In a nutshell, the FDR results supported this SEM analysis of the adsorbent, which it shows the interaction between the adsorbent and the adsorbate. So as a conclusion, the optimum values that was determined from the various graphs plotted from each of the batch absorption studies were adsorbent size 125 micrometer, ethylene blue concentration 20 ppm, adsorbent dosage 1.0 gram, and contact time 15 minutes. So this study's finding indicated that friendly fit the experiment data well. So as a result of all the experiments, it is possible to conclude that untreated corneal leaf can be used to effectively remove methylene blue dye when carried out under optimal process conditions. Recommendation for the studies. The current study investigation revealed a few areas that needed to be evaluated and researched further. The effect of pH solution and temperature on the removal of methylene blue dye from aqueous solutions. Instead of using methylene blue solution, one suggestion is to conduct dye absorption studies by using real wastewater contaminated with dye. So that's all from me. Thank you for listening.